Bonjour. Hello. Welcome to these office hours. First, I would like to address a question that was asked regarding the convergence, the weak convergence of a sequence that would not be strongly convergent. So I'm going to give you an example of a sequence that converges weakly, but that does not converge strongly. To do this, I will consider the set small l2. Small l2 is the set of all sequences for which the square of each term of the sequence can be summed. So let me give you an example of something which is in L2. That would be the sequence 1 over n. 1 over n would be in small l2, because if you look at the series of 1 over n squared, that converges. By the way, we know since the 18th century that it converges toward pi square over 6. That's a result proven by Euler in 1735. If you look, though, at 1 over square root of n, then that would not be an element of L2. That sequence, indeed, would be the sum of these terms squared would not be convergent. Indeed, 1 over square root of n squared will be 1 over n, and the series of 1 over n does not converge. So if you took calculus, or should know about these elements. Now, what I would like to say is that I'm going to consider a sequence of L2, and I will give you this example of a sequence in L2 which converges weakly in L2, but that does not converge strongly in L2. The sequence of elements of L2 is such that for each k, I have a sequence uk. So the sequence uk will be ukn. I need another index here, ukn. And for each n, obviously, I have this different number, so that's a sequence. So uk is a sequence, so I need another index, n. And I will define this sequence u1, which is 1 and then zeros. Then u2, which is 0, 1 and then zeros. And then u3, which is 0, 0, 1 and then zeros. In other words, uk is zeros and then 1 at the kth position, and then zeros, which can be written delta nk, where delta is the Kronecker symbol. Now, what I would like to say is that this sequence uk is weakly convergent to 0. The inner product of two elements of L2, say u and v, will be the sum, or actually the series, of the u and vn. So that would be u1 v1 plus u2 v2 plus all the way to plus infinity. And if there is a zeroth term, then there is also u0 v0 in the sum. Now, if you look at the sequence we just defined, uk, then if you choose a sequence v in L2, the inner product of these two sequences is, well, let's compute it. The sum, or the series actually, of these un vn, but un vn, that will really be a delta nk vn, so that will really be is this vk. So what I'm saying is that the inner product of my sequence uk with the sequence v is v index k. Now, v is a sequence of L2, so it will converge to 0. Every sequence of L2, actually any sequence of L2, is convergent to 0. So what I'm saying is that this inner product of ukv will go to 0 for every v. Doesn't matter. For every v in L2, the inner product ukv goes to 0. And when I'm saying this, I'm saying that uk weakly converges to 0. Now, the strong convergence. If the sequence converges strongly to L, then it will converge weakly to L, right? So what I'm saying is, since we know it converges to 0 weakly, the only chance for the strong convergence to take place is if this limit is 0. So what I'm saying is that since I have the weak convergence already, and I know the weak convergence is towards 0, the place I need to look at is a strong convergence to 0. Now, it may or it may not converge strongly to 0. In this case, it will not converge strongly to 0, but if it had a chance to converge strongly somewhere, that would be 0. So let's look at the norm of UK minus 0. And when I'm saying the norm, it's the norm in the Hilbert space L2, which, as we know, in this case, will be the scalar product of the element with itself. So that will be the sum of the square of each element, the series of all the square of each element. So the norm in L2 of this sequence UK will be the sum of the delta Kn squared. And delta Kn is either 0, if n is different from n, if n is different from k, and 1 if n is equal to k. So when I sum all the zeros squared plus 1 squared plus all the zeros squared, then what I have is 1. So what I'm saying is that the norm of UK minus the possible limit in L2 is 1. Well, this does not converge to 0. UK that we define does not converge strongly to 0, but it does converge weakly to 0. This is an example of a sequence that converges weakly, but not strongly. And as always, if you have a sequence that converges strongly, then it will converge weakly, no matter what happens. Here is the end of our office hours this week, and I will see you next week for more.